Hello, my name is Durga, and this summer I've been working with Placework on a project called Designing the Carbon out of Architecture. Oftentimes, when we think about carbon emissions, we think of things like energy use, transportation, and agriculture, but roughly half of global greenhouse gas emissions actually come from the built environment. Some of these emissions do have to do with energy used in the building, known as operational carbon, but a part that often gets left out is something called embodied carbon emissions. Embodied carbon emissions are the carbon dioxide emissions associated with materials and construction processes throughout the whole life cycle of a building. As shown in the graphic, the embodied carbon emissions account for the raw material, manufacturing, and transportation of the product, construction, use of the building, including maintenance, repair, replacement, and refurbishment, as well as the end of life. For my project, I calculated the embodied carbon emissions for 3 of Placeworks building designs from cradle to grave on a 60-year timescale. I use a software called Tally LCA for these calculations, which directly uses the Revit model of the building and a combination of a database and EPDs, which are environmental product declarations for emission factors. So here are my results that show the embodied carbon in Placeworks building designs. The 3 buildings I looked at were the Madbury Public Library, St. Anselm Humanities Institute, and Roberts Farm Classroom. The graph on the left shows the embodied carbon by building material for the 3 buildings, and as you can see, the materials with the highest embodied carbon are structural and lightweight concrete and thermal and moisture protection, specifically XPS insulation. The graph on the right shows the normalized embodied carbon emissions of these buildings by square meter. St. Anselm Humanities Institute has the lowest embodied carbon on this normalized metric, and this is mainly because it was an existing building reuse project, and this goes on to show the positive impact using existing buildings has on reducing embodied carbon emissions. So these results give us a little glimpse of the role embodied carbon plays on the built environment. The pie chart to the left shows the total carbon emissions, both embodied and operational, for St. Anselm Humanities Institute. These emissions were based off of the building's PEUI, which is predicted energy use intensity, and I used a tool called EC3 to calculate the operational emissions over a 60-year time period. That being said, the operational emissions do not account for the graining of the grid, so it is a conservative estimate. Even with those factors, 11% of the total carbon emissions are from embodied carbon. And as mentioned before, St. Anselm Humanities Institute already had a lower embodied carbon because of being an existing reuse building project. So with the new building project, the percentage embodied carbon is expected to be even higher. So some ways we can reduce the embodied carbon through building design include existing building reuse, like the St. Anselm Humanities Institute, and implementing high-performance envelopes and utilizing energy retrofits within the building. Some material-specific ways to reduce embodied carbon would be using purchasing of circular economy materials and products, which are products designed to extend their life cycle by being reused and recycled, or using carbon storing materials. Another way would be to be using recycled or locally sourced materials, which help reduce the emissions from manufacturing and transportation. And finally, using timber structures rather than steel or concrete, because as we saw, steel and concrete have a very high embodied carbon associated with their manufacturing. Another impact that is currently being worked on by the EPA is a forward movement of calculating embodied carbon emissions specifically in the building sector. Through the improvement of EPDs, which are environmental product declarations, we're able to get the most concise calculation for embodied carbon, even within the same type of material. By the EPA doing this work, the hope is that it will make it more streamlined for architects, engineers, and other industries in the building sector to make positive impact and work together to reduce these emissions. Thank you.